get pretty close to that microphone, sorry.
Okay, how's that? Good, okay. So, for those of you who were thinking about coming up to hear something about Mackenzie River history, you're going to be really disappointed because what you're looking at here is a site that is located over between Wagon Tire and Riley over in Eastern Oregon. You all know where that is? Okay, that's good. Most of the time that doesn't happen. So instead of talking about the local history of the Mackenzie River drainage and experiences associated with that stream channel, I'm going to talk about an ancient stream channel that was occupied as far back as 17 to 18,000 years ago. And so what we're going to be looking at here is moving back through time immemorial to a period when we can say with certainty that people were located on the Oregon landscape. And so I'm going to take you through that and talk to you about why we believe this to be true and look at the deep time of Oregon slightly further to the east. I am an archaeologist. I worked for about almost 20 years with the University of Oregon Museum of Natural and Cultural History as one of their staff archaeologists. And one of the things that I did as a part of that is I taught field schools for the University of Oregon Anthropology Department. So we would get students from across the country and around the world in some instances coming out to do a field school, and I did about 20 of those during my time with the U of O. I'm not going to give you my whole timeline of archaeology, but in November of 2023, I joined the Burns District Bureau of Land Management to become their district archaeologist, in part because it put me closer to my research area, so that as the field school experience was winding down, I started to think about how I could spend more time on the district doing smaller projects related to the research we had and tracking down the various aspects of an 18,000-year-old site. So here in this picture, this is one that was taken around 2016, if I recall correctly. And this shows the rock shelter in that shadowed area is where the rock shelter is located, and it's a very modest rock shelter by many standards. It's more of a windbreak than anything else. And so there's a rock shelter there. There's a stream channel that runs in front of it. I'll show you some more pictures along the way. But the stream channel is what attracted people to the site a long time ago. And then the rock shelter itself was just a place that people stopped intermittently and left some evidence of their time camped there, collecting various kinds of resources and so forth. So let me get this on track. So there's Eugene. I didn't think to put Walterville, but there's Eugene. The site is known as Rimrock Draw Rockshelter. It is the 3,855th site recorded in Harney County in the state of Oregon, which is why it's got that 35 HA 3855. It's in the northwest corner of Harney County, in the north half of the Burns BLM district, and it is located within about, in a straight line, it's located about 10 miles from a place called Glass Buttes, which is one of the biggest obsidian sources anywhere in Oregon. So this is a horrible schematic diagram of what the stream channel looked like. But so you can see on the left-hand side there, the rock shelter itself. It's about 3 meters deep from the drip line going back into the recessed area. It's about 20 meters long. And it is located adjacent to a stream channel that ran out in front of it that has been disturbed heavily by the work that we've been doing in the screening and so forth. So Rockshelter and the excavations are on the south side of the stream channel. On the north side, we have another excavation that's going on there. And then the approximation of this channel flow is shown by that, those two lines going off in the distance. This is taken from on top of the rock shelter. And what you can see is that if you look at the vegetation, you can see that there is sagebrush growing in the middle of the stream channel that is smaller than the sagebrush around it because there's not as much sediment there for the sagebrush to grow. So it demarcates the stream channel, and as does other evidence, but in general, the stream channel hasn't run in about 7,000 years. So we just see traces of what it once looked like. And then here is what it looked like when we first found it. I was working down the road about 5 miles from this location at a Clovis site, a site that is extremely rare in Oregon. We have about 40,000 recorded sites, and only 10 of them contain multiple Clovis type points. I'm not going to get into the details of what that is, but in the broader sense, Clovis sites are associated with mammoth kills and other types of big game animal kills in North America between about 12,800 and 13,300 years ago. So the very old sites, we were working at one. We were being supported by the district archaeologist before me, a fellow named Scott Thomas. And so he was driving down supplies 5 miles further down the road from where this is taken. And he was getting pretty sick of running errands for us on a lot of bad road to get to where we were. So he decided one day, I'm gonna go out and do some archaeology on my own, which is something really rare for a district archaeologist. We have the title, but most of the time what we're doing is in front of a computer and creating documents of various kinds to keep everybody else going. It's like in the cartoon where you see the cat looking out the window at all the other cats playing out in the yard. So that's what district archaeologists are like. But anyway, Scott discovered the site. One of the things that really interested him, and he's a really good archaeologist and very, very fine scientific mind for this sort of reasoning. Scott noticed that there was a basalt rim that was down about half a mile from where the main road is located, and he thought that looked like an interesting spot. He'd never been there before, and so he got out of the truck and started walking down there. And when he did, he noticed that as he got closer to where that rim was, he started to see thousands and thousands of pieces of obsidian, chipping debris from making stone tools. You all know what obsidian is? Volcanic glass, all of that. It's beautiful stuff. I brought a couple of examples here. But so he started to see all of this chipping debris on this bare surface around where the rim was located, and fragments of stone tools, lots of stuff just scattered across the surface. And as he got closer, instead of a few or tens or hundreds, he started to see thousands. And so there's a lot of stuff around where the site is, and that's always interesting. But in that circumstance, what he was looking at was an eroded surface. And so as archaeologists who are trying to go back in time and look at the past, we like being able to see where the sites are. But what we're really looking for is the deposition, the stratified deposition, layers of dirt that have been sitting in one place and accumulating over time. And when he got up to the rock shelter, after walking through all this debris, he looked down at the floor of the rock shelter, and there was nothing on the surface. And so in that setting, what it told him was that surrounding the site was a windblown, windswept sort of an area that had been eroded down almost to bedrock, and he could see lots of lag deposits of stone tools there. But when he got to the rock shelter itself, there was nothing on the surface except for a stem point that dates between about 7,000 and 15,000 years in age, and it was broken in two. And so it was like a sign going, hey, look, dig here, look here, study this, dig here. And it was just really, it was a really cool sort of a happening at that point in time. And so Scott came down and got me, and we brought some of the field school folks back, and we walked around the site and looked at it, and decided to start doing some test excavations. But first, we wanted to get a sense of what was there. And so,
What is the stem point?
I'm gonna show you.
Oh, good.
So this right here, this is very similar to one that we found at the site. And this is called a Western stemmed tradition style point. What makes it stemmed is that it has a long blade. This is the business end of the point, and then it has a tongue-shaped sort of a stem that fits down into a socket on either an atlatl, a throwing spear thrower, or on the spear itself. And so when we see these points with this particular blade, shoulder transition, and then base, that tells us that we're dealing most of the time with stone tools that were made before about 7,000 years ago. This one's made of obsidian. I'm just going to pass it around. That's one type of obsidian. I'll show you another in a little bit. But so he saw that laying on the ground surface, and then we decided that we would start having some of our volunteer archaeology folks come out and survey the site. And so we were not finished at the site down the road called Sheep Mountain Clovis. And we had volunteers from the Oregon Archaeological Society that came out and did citizen science for us every year. And they've done everything from pedestrian survey, walking and looking for sites and looking for tools in important sites like that point, to excavation at our sites in side by side with students. So it's been very important over the years for us to support citizen involvement in our archaeological projects. And so we sent them out for the next 2 years. They come out for about 2 weeks a year, and we brought them out and had them do survey. And they kept coming back at the end of the day with points like that. This is another type of a stem point here, points similar to this. Pass this one around to you. And other types of stone tools. So what they were showing us though is that with the consistency of the finds, we had a site that dated somewhere between about 7,000 and 15,000 years ago based on radiocarbon dating in association with those types of points. So I'm going to speed this up a little bit. So they did their surveys, and then we did a series of test excavations, and then what is called data recovery excavations, or big block excavations that you see like on Discovery Channel or OPD or something like that. So in all, we've done 7 field schools and 2 testing phases and a lot of pedestrian survey out at the site between 2009 and 2023. And actually that 52 weeks total field work at the site is at closer to 58 now. So it's one of the best years of my entire life has been spent in increments out at Rimrock Draw Rockshelter. So here's what it looked like when we were finishing up excavations in 2012. All of those rocks came from down in the excavation pits. I'm again standing up on the rock shelter rim and looking down. You can see the excavation blocks. One of the things that we never tell students is, A, they're going to have to get all the rocks out of the bottom of the units, and B, all of those sandbags are filled with sediment from excavation. So whenever we dig in the site, we bring the sediment up in buckets. We screen it to look for artifacts and burn plant seeds, lots of artifacts and ecofacts both. And then all of the sediment that's been screened goes into those sandbags and goes back into the pits. And so at last count, we were at about 10,000 sandbags. And we don't want them to know before they pay the money and sign up, then they have to take those out and put them all back. So this is the year after. We had done excavation closer to the rock shelter wall, and now we're stretching out a little, going northward toward the stream channel, so we have multiple blocks, and then a central block, and then over here out of the sight of the camera, we have a western block. So there's 3 different excavation areas going on at this time, 2013. And then this is the 2016 look. So I'm just giving you a sense of what kind of work we've been doing, how long we've been doing it, and then the scale of the excavation itself. All of the excavation is done in 5 centimeter levels. A centimeter is about, or an inch is about 2.5 centimeters. So we're digging 2 centimeters at a time using trowels and very careful methods to excavate down from top to bottom. And so we've done about 50 excavation units at various sizes and depths, but the ones I'm going to talk about most here during this presentation are units 30 and unit 2 that are over on the east side, units 18 and 19 that are in the center, and then I'll talk just a little bit about those units up on the north side, units 38 and 39, because all those factor into how we could geologically, archaeologically understand the site. Does anyone have any questions so far? Yes?
So the basalt wall is approximately there where those words are that say Rimrock Draw, right? Is that right?
No, that's the basalt wall is down there. You see that dashed line right there?
Oh.
At the lower part of the screen?
18, 17, and 1 above it?
This right here.
That dash line, okay, that dash line.
So this is the back of the rock shelter here.
Oh, got
And-
it, okay.
And that's the drip line there.
Okay.
So thank you for asking. You know, as far as I know, everybody knows exactly everything about this.
That's why we're here.
Let's see, I kind of overshot here. So one of the things that's really important about this site, and this is a terrible picture, I don't know what happened to this, but we did some trenching across the stream channel. One of the things we see consistently for the site is that we have wind-blown sediments from the surface down to a layer of Mazama ash. And that layer of Mazama ash is from the eruption that formed Crater Lake 7,600 years ago. And that sediment underneath that, across the entire site, out in the stream channel, all of that sediment underneath that is older than 7,600 years in age, because we can't see any place that that volcanic ash has been truncated or cut through. So that's really important as you get out and look at everything that's underneath, because what we're talking about here is the principle of superposition. And then that idea is that the oldest things are going to be buried underneath the more recent deposition, if everything is in its original position and hasn't been eroded or modified through animal activity or whatever. So in a laundry basket, you start putting your clothes in there on Monday. By Friday, it's getting pretty full. All the oldest stuff is down below, all the more recent stuff. Unless you went digging through the laundry basket to find a shirt you really wanted to wear on a date, you know, and didn't have time to wash it or something. Let's see. Okay. And then that was out in the stream channel. This is in the rock shelter itself, and this is one whole wall where we excavated a unit. And you can see here, or I'm going to tell you, so you can see that you have wind-blown sediments that go from the surface down to that first thin line. Underneath that, you have modified deposits that are from a marsh that was located there. And then below that, you have stream channel deposits. So we have a three-part sequence that we can see also across the site that consists of stream channel deposits, marshy deposits, and then wind-blown deposits. And the difference is that as you get through the marshy deposits and into the wind-blown deposits, that tells you you're going from water to desert. And also in this picture, you can see that there's a lot of big chunks of rock that I've highlighted here. And those are from a wall collapse. The rim wall collapsed at one time, about 10,000 years ago, we think, and buried a whole layer of archaeology underneath it. So
Could that have been from an earthquake, maybe?
that's kind of what I'm leaning toward, yeah. It's a possibility for sure. And then, so the questions we were asking out at the site is, how did humans use the rock shelter? How old is it? What are the geologic influences? We're not as interested in the erosional or, things being scoured and stripped off of the landscape. We're interested in the deposited layers that protect old archaeology. And then what is the paleo-environmental context of the site? What are the plants that were located there at the time the site was occupied? What kinds of animals were there? And so we know from, and I'm just trying to go through a quick overview of things I'm going to talk about later, but we know from looking at the archaeology of the site that we have stone tools that are diagnostic of certain time periods. And so the stem points, like I was passing around there, all of those stem points date prior to about 7,000 years in age. It's not until after that we start getting points that are notched on the sides or in the corners. So up at the top there, you can see some of those points that have been notched on the sides or in the corners. We don't have very many of them, so I don't have some very good examples to show you from the site. Down at the bottom, we have more that are circled also. But in all, we have maybe, at this time, we have maybe a dozen that date after 7,000, 6,500 years ago. In all of the older types of points that date prior to that, we have over 100. So this is just something that tells us, considering how close Glass Buttes is to this site, that people were not coming here in any great numbers after a certain time period around 7,000 years ago. And that ties in with the eruption of Mount Mazama, the wind-blown deposits that come after that. So something killed the hydrologic system of the area that may have been associated with Mazama. And then after that, we get nothing but desert winds blowing stuff into the site. So these are some of the stem points we see from the site, like the ones I was passing around to you. Some variations, some that are more foliate or leaf shaped. So there's one, the 1, 2, 3, 4, the fifth one from the left in the top row is called a Hasket point. And those date between, roughly between about 10 and 12,000 years. And here's one of those. That's made of Glass Buttes obsidian. So you can see, as I pass these points around, you can see the differences in the types of obsidian that come from the site.
Did you call that a hatchet point?
A Hasket.
Hasket.
Yes, H-A-S-K-E-T-T.
Okay.
And they're very distinctive. I think they're aesthetically one of the most beautiful projectile points that we see out in the desert. And I think you'll understand why when you see that one. The other thing that we're seeing from the excavations is specifically underneath the rock layer that I was talking about, are these very fine, high-quality gravers, scrapers, perforators, things that are made for specialized crafts. So these are not the tools that people carried around just on a regular basis. These are tools that seem to be more associated with specific kinds of tasks that people were doing at this site and at other sites too. When you see this really fine quality cryptocrystalline silicate, or what's also called chert or jasper, and with these multiple beat tips on it, and that all tip on the second one from the left. This one over here on the right has a concave scraper. On the left side, it has a convex scraper on the right side, and then it has a graver, a little bit at the top. It's a very high quality, very specialized type of tool that was made to do certain things that projectile points aren't made for. And then the other thing we have at the site are crescents, and these are infrequent finds. Crescents are found associated with, generally with shallow lakeside archaeological sites dating between about 8 and 13,000 years ago. And we don't know what they were used for. They are considered to have a use as either as a projectile point mounted on the end of a spear thrower so that this was facing forward. But it also seems likely that they were used as a cutting implement, as some sort of like a handheld sickle for gathering plants at the edge of a marsh. Because they show up in those old marshes like that, they seem to have a very specific task. But we haven't found one hafted yet that will tell us whether it was used to knock ducks out of the air or to cut bulrushes at the edge of a lakeside. So here's a crescent here. And this is made out of fine quality chert. We know that obsidian has geochemical qualities that make it different from one source to another, and we have over 100 sources identified in Oregon for our abundance of obsidian that we have here. And the obsidian that you can see here, that yellow dot is the site. Those obsidian sources up there are at the north end of the Burns District going up towards John Day and over towards the Fort Rock Valley to some degree. So the majority of the obsidian is coming from within about 50 miles of where the site is located. But then we have some from over in Klamath Country, Silver Lake, Sycan Marsh, some from over by Summer Lake, some from California, Nevada, and over on Steens Mountain. So what people were doing is they were making stone tools at obsidian sources, putting those on spears or spear throwers, darts, and then if they lobbed them at some animal and it broke on the rocks, they would carry it to the next stop, not take the point out and replace it with a newly fashioned one. So that's why we see so many broken points in the site on the surface. So the plants that we have coming from the excavations include fuel woods like rabbit brush, juniper, and sagebrush. So you see that from top to bottom. And then in the fire pits, where people were gathered around cooking things and having warming fires and that, we have plants that include medicinal plants such as willow, and also utilitarian plants. Willow also, serviceberry, chokecherry, bitterbrush, food plants, wapato. So you have food, medicinal, and utilitarian plants that are all showing up in these fire hearths that aren't showing up in the rest of the site. And so that tells us that people were carrying those things from nearby and that the environment looked a lot different at the time they were gathering those plants. So here's a picture that you can't see the fire hearth very well, but this has bulrush seeds that were burned that date to about 9,500 years in age. These are wapato seeds. Wapato is an Indian potato. If you know the Shuacan Marsh down in down to the south of Summer Lake, Shuacan is the Klamath word for potato, or for this type of plant, and we have those in the 10,000 year range. So those are seeds coming out of fire hearths, and we have deposits that go from 4,500 to 10,000 years in age, based on the plants, and all of those sites are, or all of those fire hearths are above the rockfall that I was talking about earlier. So what happens after you get through the rockfall, and I'll show some more pictures here of the rockfall and what that looks like, so you get a really strong sense of how separated the desert wind-blown deposits are, and the marsh deposits from the river deposits that are underneath. So for this, I'm going to talk about two different sites, or two different units. The east side of Unit 2 and a portion of Unit 19 and all of Unit 18, which is about 4 meters to the west of Unit 2 there. When we were digging in 2012, we did our first field school there, and we started to come down on a layer of rocks that were very, it was intense working in that location, and it was a place where we could see that as we were digging, these looked like desert deposits, some marshy deposits, but it didn't look like what we would expect to see on bedrock. That kind of oxidization that comes with minerals being pulled out of basalt and forming that orange sort of dense clay that you would expect to see on above bedrock. So we thought, well, we've got to try and get underneath this rock layer and see what's here. And we got a guy to come out and help us who is used to splitting rocks using wedges and feathers. And so we started taking out some of these big rocks that were in the excavation and busting them into the chunks that you see up in the pile up on top there in the earlier slides. After he got through the rock layer and we had students under there digging underneath that, we found that we were correct. We were lucky, most of all, but we were also correct that we had deposits between the rock layer and bedrock that had archaeology in it. So you can see these guys working underneath the rocks. And in that 2012 season, we found at the very end, the last day of excavation, which is the way it always happens, we first found a layer of volcanic ash from the eruption that we thought was Mazama. It was from what we thought was Crater Lake explosion. And so when we found that, we kept going and dug down and found another layer that had big chunks of tooth enamel in it. And so these are chunks of tooth that didn't look like anything that we have on the landscape today, and it turned out that was correct. And then underneath the rock layer, or underneath the tooth enamel layer, so these are 10 centimeters from the volcanic ash to the rock layer, or to the tooth layer, and then 10 centimeters from the tooth layer, we found this orange chalcedony, or really high quality silica rock stone tool. And so going back to that idea of superposition, if things are in their original state and they haven't been modified through the ground disturbance or erosion or anything, then the tooth enamel should be older than the St. Helens ash, and the chalcedony flake tool should be older than the camel tooth enamel. And that winter we sent off samples for identification for the volcanic ash, and found out that it was a layer of ash from the eruption of Mount St. Helens that occurred between 15,300 years ago and 15,600 years ago. I went and worked with Edward Davis at the University of Oregon Condon Paleontological Lab, and found that that tooth enamel fit very well with camels that were excavated out of the Ventura Formation to the east of Burns. And so we had volcanic ash 15,300 years in age. We had camel tooth enamel that was undated at this point, and then we had that stone tool underneath it. So if that sequence is in order, the camel tooth enamel should be older than the volcanic ash, and the stone tool possibly older than both of those things. And so here's what it looked like when it came out of the ground. We did some studies on the blood residues that might be present on that piece of stone, and found out that it had been used to butcher or process a bison. And then here's that tooth enamel. So there it is. There's some of the bigger chunks that we got out of the excavation unit. There's the chunk that's in a student's hand, and I picked a student that had very small hands because it looks like, you know. And then this is a camel maxillary or upper jaw fragment from the Ventura Formation with our piece of enamel next to it. So along with that, we found, that was in 2012, and so we've been chasing ever since, trying to figure out whether the deposits line up from one side of the rock shelter to the other. And if we could match the dates on the camel tooth enamel with other tooth enamel. And in 2021, on the last day of excavation, we found underneath a rock that the students split out and lifted big chunks of it out and started digging underneath, they found that big camel tooth incisor. So it's a tooth from the front of the mouth, and the root's missing, but it's shown next to a bison incisor that is from a 1,200-pound animal, and then an elk incisor it's not a big elk, but just for comparison, it shows you how massive camels were on the landscape back in those days.
So are you saying the camel was a giant?
It was pretty good size. It wasn't, there were bigger camels, but this, you know, it just shows you how these animals are so much larger. And then I'm pointing this out. So this is, I showed you that fellow breaking out the big rocks in Unit 2, and this is over to the west about 4 meters in Unit 19, and we're going down from 220 to 225 centimeters. And this shows you how dense the rocks were in that place. And the reason this is so important is that it indicates that we have little opportunity for up and down movement of artifacts going down towards the bedrock, or artifacts being pushed back up by bioturbation or animal burrowing. So we have to excavate around the rocks, get them mapped, photographed, take our samples, collect everything we can in situ or in place. If it's a piece of an obsidian flake that's the size of a fingernail, it got mapped in situ. And so we had to be very slow and cautious about this. So from 2012 until 2021, that's how we were excavating the site. And and here is, this is 40 centimeters below. You can see we're just starting to bust down through the rocks in Unit 18, which is next to 19, and we're finding bison tooth enamel fragments buried underneath that rock layer. So what we found out is that the camel tooth enamel was dated by Tom Stafford, who's one of the world's best radiocarbon dating experts. He's done incredible work on some of the most important sites around the world. And he got really involved in this project, and he dated the camel tooth enamel to 14,975 radiocarbon years, which equates to 18,360 calendar years. So there's an offset between radiocarbon years and calendar years, and I don't want to like have you passing out here with me going into the fine details. So I just want to point out that when we are talking about time in our common, you know, in our vernacular, we're talking about calendar years. And so in Unit 18, where we were finding the bison tooth enamel, we are finding that that bison tooth enamel is 17,000 to 17,000. Well, actually to 18,000. I'll show you some more dates here in just a jiffy. And then also in an association with the tooth enamel fragments that are in the 17 to 18,000 year time range, we're finding stone flakes and stone tools that were used to butcher these animals. And we have those with blood residues of horse, bison, and mountain sheep. So people were at this site processing animals that are 3 different species. Also, there's sage-hen there too. So we have prairie chickens too. And so as we're looking back through what we've done at the site, we've discovered that along with that chalcedony stone tool in Unit 2, over in Unit 19, where we're getting the old dates, we have another piece of that same stone that's showing up there. So we can see that the layers, the materials that are in the layers, including those tooth enamel fragments, the tooth enamel fragments, the stone that's present there, the type of materials that are made on this very unique piece of stone. And then the form of the stone tools is similar too. And so the orange one had bison blood residue, that big obsidian flake had horse blood on it. So, and these are all extinct species from that time frame. These are not modern bison. Horses died out about 11,000 years ago. Camels died out around 13,000 years ago or so. So we're looking back in time quite a ways. And we're matching the deposits from underneath that rock layer from one side of the rock shelter to the other. And we are able to say with a great deal of certainty that those deposits were protected. We have stone tools in association with the bison tooth enamel, with the camel tooth enamel. And then we have sheep, horse, and bison blood on stone tools as well.
Wow.
So the deepest deposits are pristine, not redeposited. We got that first round of dates in 2015, or I'm sorry, 2018, and then we had a new round of enamel fragments to send into Tom for dating, or Tom prepared them for dating by UC Irvine, and that happened in December of 2019, and then 2020, everything shut down by March, and we were not able to get our dates back until 2023. But the dates that we sent in to reconfirm the original dates all match up with the originals within 20 or 30 years. So anyway, that's what, when we talk about ancient people in Oregon and who was here on the McKenzie drainage and when they could have been here, these are things that you need to think about, is that we have a record of people being here 18,000 years ago, 17 to 18,000 years ago, at Paisley Cave, which is another rock shelter in eastern Oregon. We have dried human fecal material that's been radiocarbon dated to 14,300. We have Cooper's Ferry up on the Idaho side of the Snake River. We have radiocarbon dates of 16,000. And then at White Sands down in New Mexico, we have pretty strong dates for humans walking along the edge of a shoreline around between 21 and 23,000 years ago. So people have been here a long time, and Oregon has been one of the best places to look at the human past. So I'm going to move through this really quickly, but this is Tom when he was out working at the site. He not only did the radiocarbon dating of the tooth enamel, but he also did the sedimentology. He looked at the sediments to make sure that he agreed that what we were seeing was intact, protected deposits. And when he would explain things, he'd write those points that he was making with a Sharpie on his hand. So he'd be like, getting really excited talking about this and that. And it was fabulous. He was so great to have out there, but I always had to photograph his hand at the end of the day, just so that I could make sure I had everything in my notes.
Sounds like an
And so I'm going to go very quickly through this, but Tom reaffirmed that we had a 3-part sequence: windblown sands and silts over Mazama ash, Cienega deposits, or quiet water, marshy sort of deposits at the site. And then down at the bottom, we had high energy boulders and pebbles from a stream that ran in front of the site 18,000 years ago. And then this is a picture of a big trench with the windblown sediment shown at the top, Mazama ash sitting on top of the marsh clays, and then the rocky boulder deposits of the stream down below. So I wanted to get to this one because this shows the marshy deposits, the black muds that are down below. There's a primary deposit of Mazama ash from the eruption that occurred 7,600 years ago that settled right on those marsh clays and stuck. And then the material that landed on the ground in other portions of the landscape surrounding it got blown in and settled on top of it. So we have a pretty clear evidence of the original eruption event right there with that little thin white band right atop that crack. So the sediments are so different from one to the other that when the edge of this trench dried out, the stratigraphy cracked, everything separated, and so you can see very distinctly how different those materials are from one side to the other. And then, let's see, I'm going to blow through this. So where is the water coming from? There's, because well, let's go back here. No, let's not. Sorry, I'm running out of time, I know it, and I just want to make sure that I don't get this too deep into the weeds. But so the rock shelter is over, let's see. Actually, what we can see is this is the landscape currently, and we have 3 playas out there that are very large. Playas are dried lakes, and they sit in a big basin that is right above, or right to the south of where the rock shelter is, which is that orange dot there. So that's what we can see as far as where the playas are, and it looks like they all sat in a big basin. So I went out there in 2000. I couldn't have a field school, so I went and camped by myself and walked all the drainages and walked the edges of that playa basin. And it was terrible, I tell you. It was just a month old myself out in the desert exploring. It was awful. But so here's all the stream channels that are flowing in. And then what I did was I just took a topographic line along the edge of the basin and marked that as a potential lake shoreline. And what you can see is that there's a single outlet that is between Juniper Ridge and that low ridge over to the northwest. That ridge was blocked at one time, so there was a single outlet that came from this big lake basin and flowed up into the channel that went past the rock shelter. So, you know, we've wondered for ages how we could justify the size of those big boulders that are down in that channel and all of the rounded rocks in a desert landscape that has very little topography in general. But the reason is that it had a big charging point that was coming out of this lake, and during flood events, you were having high velocity sorts of pushes of energy through that channel. And then we can see evidence of the wave or the lake and the wave activity along the lake in the playa here. This is Rimrock Playa, and you can see there's actually a wave cut notch where that red arrow is. So the lake surface came up at least to that point, and it eroded all of that rock back. So what that tells you is that that lake stood there for a considerable length of time to have the energy to do that. And then this is what it probably looked like at that lake, and you know, as it's viewed in modern times, the kinds of resources that would have been there. I'm gonna skip that. So we've done multiple dates on the tooth enamel, and we have tooth enamel that dates from 11,000 back to, these are radiocarbon dates, so on the left side, so 11,000 back to 15,000, and in calibrated dates from 13,000 to 18,650. So Rimrock draws a time capsule of human activity between the end of the Ice Age and the eruption of Mount Mazama. Something happened at that point when Mazama landed on that marshy deposit. Perhaps the seismic activity associated with that eruption. We can't say that for sure, but the archaeology and the environmental considerations tie together in a way that suggests that. So what we can say is that water stopped flowing through that stream channel or being collected in that marshy basin after the eruption of Mount Mazama, and all we see is dust and silt and sand and volcanic ash blowing off of other landscapes, and no new channel creation in that stream after that point. The archaeology tells us that the most common types of points we find in the Great Basin are those notched points, and they occur after about 6,500, but we only have a handful at the site, and all the other older points are, we have well over 100 of those. So it just tells us that when that eruption happened, there wasn't water anymore for whatever reason, and people stopped coming to that site, camp there with any frequency, even though Glass Butte is 10 miles away, and it was one of the best local sources of obsidian. Glass Butte got carried all the way from the source to the Klamath, the mouth of the Klamath River. We have wagon tire obsidian nearby that's been found in Lake Huron. We have other obsidian from Newberry Crater that's found in Tennessee. So, you know, the material got carried, and there was a reason to come there because of not only the utilitarian use of obsidian, but also the trade qualities of it. It was a good obsidian to trade up at the Columbia River Trading Centers or other places. And so if there was water, people would have come to that site, but we just don't see it. And so anyway, there's the crew from 2021. And then there's the obligatory sunset photo.